Hello student, we learn in the chapter of current electricity how the potentiometer can be used. What are the difference between voltmeter and potentiometer? Voltmeter is a portable, but potentiometer is the wooden block of 4 meter wire is kept on it. Therefore, potentiometer is not portable. It can be measured accurate potential difference with the 2 points, but voltmeter is also measure the potential difference, but it cannot measure the electromotive force or EMF of a cell. Therefore, potentiometer is not portable and voltmeter is the portable instrument. Now we study about what is meant by galvanometer. Galvanometer is a device which detects a very small current can be flown in the circuit that can be detected with the help of galvanometer. Therefore, galvanometer, the internal structure of the galvanometer, the 2 poles, magnetic poles, north horseshoe magnet or poles, N pole and S pole, can be pivoted with a rectangular coil. It is a moving coil. Hence, it is also known as moving coil galvanometer. The coil is pivoted with the help of pointer, shows a deflection on that galvanometer. That pointer shows a deflection, a very small current can be flown through it. Therefore, to show the galvanometer a large deflection, hence current is directly proportional to the deflection. In galvanometer, current is directly proportional with the deflection of the galvanometer, means I is directly proportional to theta. In that manner, galvanometer used as when the very small current flow through the circuit, it can be measured with the help of galvanometer. Hence, galvanometer acts as an ammeter. Ammeter is a device which can measure the large current flow through the circuit. Therefore, galvanometer acts as an ammeter. How it can be measured? The current in the circuit, when MCG converts into ammeter, when a small resistance or shunt resistance is parallel with the galvanometer, is connected with parallel the galvanometer, therefore that combination gives galvanometer connected with the very small resistance, shunt resistance in parallel combination that shows the MCG converts into ammeter, where R is the resistance connected in series, where R is connected in series, the I flows its resistance R plus G. That resistance increases, therefore no damage of galvanometer. But when the shunt resistance is connected in parallel with the galvanometer, therefore the current splits into 2 arcs. First is the galvanometer flowing through that current is known as Ig, and the series shunt resistance Rs. It is also known as shunt resistance. Parallel resistance connected with the galvanometer, then it is known as shunt resistance. Therefore, R splits into Ig and Is. Therefore, equation can be written as I is equal to Ig plus Is. Then I minus Ig, that Ig can be transferred in that side, therefore I minus Ig is equal to Is. Where the galvanometer and shunt resistance are connected in a parallel combination, therefore potential difference across galvanometer as well as shunt resistance is the same. Potential difference across the galvanometer from that 2 points, and that 2 points the potential difference is same. Therefore, the potential difference across galvanometer, PD across galvanometer and shunt resistance, PD across galvanometer and shunt resistance. Potential difference means voltage. Voltage across galvanometer and voltage across shunt resistance. According to Ohm's law, that voltage can be calculated by current flowing through it, Ig, and in galvanometer its resistance is G. Therefore, G into current is Ig. Gig, potential difference across the galvanometer, Vg is equal to G into Ig, where G is denoted by resistance of galvanometer. G is known as resistance of galvanometer. Therefore, PD across G and S both are equal. Therefore, that side equal sign, the potential drop across S. But the current flowing through that S is denoted by Is. Because of shunt resistance carries a Is current and galvanometer carries a Ig current. Therefore, I split it into Ig plus Rs. 2 arms. It divides into, the current is divided into 2 arms, Ig plus Rs. Therefore, current passing through that Is with the resistance S, therefore potential difference across that S is equal to S into Rs. But from that equation we get the condition for Is is equal to I minus Ig. Substitute that value, G into Ig is equal to S into, substitute the value of Is is equal to I minus Ig. Therefore, G into Ig upon that I minus Ig factor, I minus Ig. We get the shunt resistance. Therefore, S is equal to Ig upon I minus Ig into Vg. And that formula can be used to find the shunt resistance. Is is equal to Ig upon I minus Ig into G. Where the shunt resistance value, 1 milliampere current flows through that circuit. The shunt resistance value means its value is very small. Therefore, shunt value Is is equal to Ig upon I minus Ig into G. And the ratio of the current means G is equal to G into Ig is equal to S into Is. Ig, substitute the value of Ig. Ig is equal to I minus Is. Ig is equal to I minus Is. Then G into, now G into I minus Is is equal to S into Is. Therefore, G into I minus G into Is is equal to S into Is. Therefore, G into I is equal to Is factors G plus S into common factor is Is. Therefore, I upon Is is equal to G plus S upon G. We can calculate the ratio of the current. I upon Is is equal to G plus S upon G. By using that formula to calculate the shunt resistance value and shunt current, its ratio, that formula can be obtained when galvanometer is converted into an ammeter. How MCG is converted into an ammeter? Ask the board exam question paper. How MCG is converted into an ammeter? When MCG is converted into an ammeter, when the shunt resistance S is denoted by parallel resistance, parallel connected with the parallel, that parallel resistance is known as shunt resistance is connected with parallel to the galvanometer. Therefore, I is equal to Ig plus Is and I minus Ig is equal to Is. Potential drop across G and S both are equal. Therefore, Gig is equal to SIS, and substitute that value and we get the condition for S is equal to Ig upon I minus Ig into G. That formula can be obtained from that relation by using Ohm's law. V is equal to IR. V is equal to I into R, where G is the resistance of galvanometer. MCG converts into voltmeter, where a resistance X is the high value resistance, where shunt resistance in an emitter, shunt resistance is a small resistance, but voltmeter, a high value resistance, is connected in series with the galvanometer. That combination is known as MCG is converted into a voltmeter. High value resistance is connected in series with the galvanometer. Therefore, galvanometer acts as an voltmeter. The potential drop across the series combination of resistance X and G, where galvanometer, where the high value resistance is connected in series and current flowing through them is Ig. Therefore, by using that relation, Ig flows through X as well as G, means Ig into Igx plus Ig into G. That is the potential drop across the component. Therefore, V is equal to Ig into X and Ig plus Ig into G. Therefore, V minus Ig into G, V minus Ig into G is equal to Ig into X. To calculate the value of the series combination high value resistance, X can be calculated. X is equal to, that Ig can be transferred in that side, therefore V upon Ig. V minus Ig into G upon divided by Ig. We get the equation for X is equal to V upon Ig, where Ig is denoted by current flowing through the galvanometer and V is the potential difference, voltmeter. The voltmeter range of voltmeter can calculate the some voltage across the combination. Therefore, range of voltmeter, it is denoted by V is denoted by range of voltmeter. V upon Ig minus divided by Ig upon Ig into G, but Ig upon Ig get cancelled. Therefore, V upon Ig minus G is equal to X. That high value resistance can be calculated by using that formula. X is equal to V upon Ig minus G, where G is the resistance of galvanometer, V is the voltmeter range, Ig is the current full scale deflection of the galvanometer when current is flowing through that. Therefore, X is equal to V upon Ig minus G. That formula can be used where the resistance value is high, where resistance value is high because of the series combination of the resistance. Therefore, there is no damage of the galvanometer, hence where resistance value, series combination of that resistance, its value is higher than that of the emitter. Means emitter मध्ये जी व्हॅल्यू येते शंट रेझिस्टन्सची ती स्मॉल येते आणि व्होल्टमीटर मध्ये जो रेझिस्टन्स कनेक्ट केलेला आहे त्याची व्हॅल्यू काय येते हाय येते. because of high resistance should be connected in series combination with the galvanometer. Now we see the example of how the MCG means galvanometer converts into an ammeter and voltmeter. Example of that, on that topic, a galvanometer has a resistance of 40 ohm. Galvanometer resistance means given data. Solve that example. Given data, that resistance is the resistance of galvanometer means capital G. Resistance of galvanometer, it is denoted by capital G, is equal to 40 ohm. And current of 4 milliampere means current flows through that galvanometer is 4 milliampere. Means Ig is equal to 4 milliampere. Means 4 into 10 raised to minus 3 ampere. Needed full scale deflection. What is the resistance and how it is connected? Converts galvanometer into, first converts ammeter. How it is converted into an ammeter? The resistance should be connected. It is a shunt resistance, means the resistance is connected with the parallel combination of resistance. It is known as ammeter. It converts, MCG is converted into ammeter. And when resistance is connected is in series, then the galvanometer MCG is converted into voltmeter. Therefore, first part of that example, into an ammeter of range 0.4 ampere. Ampere constant means its range is I is equal to 0.4 ampere. Therefore, galvanometer converts into ammeter, that resistance small value resistance is shunt with G. Shunt with G. G is the resistance of galvanometer. Therefore, resistance connected with the shunt resistance, but it is in the parallel combination where G and shunt resistance, that current is I, but Ig and the current splits into Ig and Is. Therefore, by formula using of that, galvanometer converts into ammeter. Therefore, the potential drop across each component is same, means Ig into G is equal to Is into S. But where Is is denoted by I minus Ig. Ig into G is equal to I minus Ig into S. Shunt resistance S. Therefore, S is equal to Ig upon I minus Ig into G. Ig upon I minus Ig into G. Substitute that value. G. Ig is equal to 4 into 10 raised to minus 3. 4 into 10 raised to minus 3 upon 0.4 ampere means 0.4 minus Ig is equal to 4 into 10 raised to minus 3 means 0.004. 4 into 10 raised to minus 3 means 0.004 into where capital G is, its value is 40 ohm. Then calculate the value of 4 into 4 means 60. 60 into 10 raised to minus 2. 60 into 10 raised to minus 2 upon 0.4 minus 0.004, where that subtraction is 0.396. 0.396. They calculate its value is 0.4040 ohm. Its value can be calculated by using, because of 0.4 ने डिवाइड केले याला तर 4 चौक 16 म्हणून इथे आन्सर आलं 0.4040 ohm, where the shunt resistance is, it is the small value. Its value is small. Shunt resistance is small. Ammeter measures current. Its value is small value resistance should be connected in parallel with the galvanometer. Their value is small, very small. And second part of that example is MCG is converted into voltmeter. Second part, B part, MCG convert into voltmeter. Voltmeter. Voltmeter, how it can be converted? When the very high value resistance is connected in series. High value resistance is connected in series. Potential drop across the component V, X and G. Therefore, that current flowing through that is Ig. Therefore, V is equal to Ig into X plus Ig into G. Therefore, V upon Ig is equal to X plus G. Calculate the value of series combination of that resistance, high value resistance. Therefore, X is equal to V upon Ig minus G. But into the voltmeter of range 0.5 volt, voltmeter construct करायचा आहे, पण त्याची रेंज कुठून पाहिजे, किती पाहिजे, तर 0.5 volt पर्यंत. Therefore, the value of V is equal to 0.45 volt. We know about Ig. Ig is equal to 4 milliampere. G, capital G is equal to 40 ohm. Then substitute that value. V is equal to 0.5 upon Ig is equal to 4 into 10 raised to minus 3 minus G is equal to 40 ohm. Therefore, that series combination of resistance means high value resistance. It can be calculated by using that conversion, means 10 raised to minus 3. 0.5 into 10 raised to 3 means 500 upon 4 minus 40 is equal to 4 चा मग याने याला डिवाइड करा आणि त्याच्यातून 40 मायनस करा, means 85 ohm. Its value can be calculated about the 85 ohm, means high value. High value resistance should be connected in series. Then MCG is converted into voltmeter. Voltmeter measures the potential drop, potential difference across the component. Hence, voltmeter is the high value resistance is connected with, is in series with the galvanometer. What is the difference in between the voltmeter and ammeter? When galvanometer converts into ammeter and galvanometer converts into a voltmeter, at that problem that converted into an ammeter as well as voltmeter. One problem can be asked in that question paper. Therefore, MCG is converted into an ammeter, 2 marks, and both the galvanometer converted into an ammeter and the MCG is converted into a voltmeter. Therefore, that problem can be asked in that question paper for 3 marks.